Hi, I'm Ahnaf and I'm going to start off with some background about the software.
Oh, damn, these huge matrices. What? What's this?
This, my friend, is the end of all your worries. So here we have a linear system of equations from one of the Math 102 assignments, and as you can see the matrix which results is quite huge. So what we have done here is convert all those linear system of equations into a matrix, and then we load this file in our program. Here it tells us that our matrix is an integer matrix, and if we row reduce them we can get a row echelon form which retains all the integer values. Once I enter yes into the program, we're given all the steps which we need to take to achieve this row echelon form, and we can see that this solution is exactly what we expect. It also gives us information about the rank and nullity of the matrix. Then we're asked if we want the row reduced echelon form. If we say yes, we get the RREF form as expected. Then we're asked if we want a row echelon form where the rows are orthogonal to each other. If we say yes, we get two outputs. The first output is the row echelon form where the rows are orthogonal to each other, but the row vectors do not have a norm of 1. Therefore, we have a second output where the row vectors do have a norm of 1. We're also provided with the steps taken to convert this matrix into this. We are then asked if we want Gram-Schmidt applied to the column vectors of the matrix. This allows us to obtain a basis for the column space which are orthogonal to each other. When we say yes, we get another prompt which asks us if we want the basis vectors normalized. I'm gonna press yes, and there we go. We get an error because the first row has 3 columns while the second and third row they have 4 columns. We are given a chance to fix our file and load it again. There is an error in this case because the matrix contains non-numeric entries such as letters. Again, the program provides us an opportunity to fix it. Here I have the timeline of the software development process. The timeline is divided into two parts. The first part focuses on the software development which took place during February, and the second part focuses on what happened during March. Here I demonstrate the first working version of the program called M1. In this version, all data needs to be entered painfully into the command line. The values can't be modified once entered, and any error will abruptly shut down the program. Then in the 5th week of February, I rewrote the whole algorithm. Let's call this version M2. Now this algorithm works better than the previous one, and it accepts any m into n matrices. This is version M2 of the program. As you can see, it's divided into several different modules now. There also is an option to load from a text file achieved using the load function. This is limited since we can't use fractions. The algorithm also didn't work for certain inputs. Over the weeks of March, the program was made much more sophisticated and advanced. The algorithm was rewritten twice, and the ability to produce different row echelon forms was added. The Gram-Schmidt algorithm was also implemented. This here is the final version of the code. It's divided into 8 different modules and has a significant chunk of code. MATLAB's specialty in dealing with matrices greatly helped development. A major example is logical indexing, finding a matrix transpose, or flipping a matrix. Since there are infinitely many matrix systems which are possible, making the algorithm work with all of them and produce the correct solution was challenging. Most of the time an algorithm worked with almost all inputs but broke down for some. These inputs had to be analyzed and the algorithm modified to account for general cases of such matrices. Also, dealing with the data file wasn't trivial. Since the user can input whatever they wish, we need to keep in mind any invalid input and account for them. All the code written for this software is the work of my own. I would argue that this software is unique in the sense that there are no row reducers available which produces the different kinds of row echelon forms as demonstrated. Also, using a text file for input is very convenient since small modifications can easily be made. I would like to give special thanks to Dr. George for increasing my knowledge about the topics relevant to this software.
So, what do you think?
I think this will help me a lot doing the assignment much more quickly. Thank you so much.